Now, this illustration deals when to apply correction factors. In accordance with NEC 310.14, A as in apple, 2, exception. Now, first of all, let's review together the notes. Note 1, ambient temperature on a roof sometimes is much greater than the 86 degrees Fahrenheit that's allowed in Table 310.16 in the NEC. Note 2, ampacity A shall be permitted to be used instead of ampacity B due to only 7 foot of conductors being exposed to a temperature higher than 86 degrees Fahrenheit. Note 3 says for rooftop conductor installations, see 310.15 E as in Ed, and figure 8-26. But now notice we have a first floor here where the panel board is installed, and we have an ampacity A. EMT is run in an ambient temperature cooler than 86 degrees Fahrenheit overall in the floor 1 area. So we have a 90-foot run. When we take 7 foot, from 90 foot, we come up with 83 foot that has a lower ampacity rating because we're in the 86 or less ambient temperature. But on the second floor, we're routed through 9 foot of 100-foot temperature, which is greater than 86 degrees, but only 7 foot is routed there. So in the calculation 1 at the very top, we have ampacity B, which is the second floor. 7 foot is less than 10 foot. Calculation 2, 10% of 90, we're allowed 9 foot. We only have 7 foot, so that's less than the 9 foot that's allowed for the 90-foot run. But now, sometimes the authority having jurisdiction of the state, county, or city, they may want to measure starting where the conduit emerges through the floor into the second floor and routed to the equipment. So as a designer, installer, inspector, you want to check this out. Now, if you use NFPA 70B to deal with heating problems, then you could check where these conductors terminate, and if you do not have back at the panel board on the first floor a insulation problem, overheating, slow melt, baked out, separating from the copper or the aluminum, and none of this type of conditions are visually seen at the equipment or the panel board, well, usually you don't have any heating problems anyway. But we would start with NFPA 70B as in boy, and you look at 15.1.3. That would send you through the sections that you really need to look at, which we go through in great detail in our NFPA 70E workbook. But notice what is required here. Either it starts at the panel and routed to the equipment and the 10% rule applied, or it's applied on the second floor where the conduit emerges into the second floor and is routed to the equipment. This is the interpretation of the authority having jurisdiction, which method they're going to allow the designer and installer to use. But notice one thing as electrician, do not route these conductors in areas where higher temperature could be present, and you're routing it in a different procedure and method than the designer designed the system to be routed if you had a set of plans. If you're going to change routing, check with the authority having jurisdiction. You know, for example, you could walk into a Walmart or a Home Depot, and those conductors will be down in raceway systems, routed across the bottom of the joist down about 3 to 4 foot, sometimes even maybe 5 foot. They're getting those conductors and conduit down lower so that the heat that rises to the ceiling won't affect the heating of these conductors where ambient temperature is involved. And that's what this figure 8-12 is showing. You have a 86 degree temperature or less routing. And if we route it through higher temperatures, we have to derate for the higher ambient, as you see in this illustration.